Today we are going to talk about an agent-based model designed to analyze how different kinds of people interact with their work environment and how the environment, in turn, shapes them. This model examines the dynamics of work environments by, simulating different worker strategies, showing how these behaviors lead to certain organizational patterns over time. So, before we get into the details, could you please introduce yourself?
Well, good day. My name is Alan Duggar. I'm a political scientist by training. This agent-based model specifically was a COVID project. I wanted to look at sort of macro level outcomes of different distributions of personalities or strategies in an instrumental organization. That's
To begin, can you explain the main objective of this model and, what key aspects of workplace behavior or organizational culture are you aiming to simulate?
one of the things I was looking at here is what's the difference between agents' perspectives when they make judgments based on absolute performance versus change in performance over time. The model overall explores the interactions among different workplace personalities and how they measure the performance environment and the resulting choices. So you've got three personalities. So that's both the strategy or the decision rule plus how they affect their environment. The worker, the shirker, and the poser. That seemed relatively clever. So the worker is the person who produces a lot and inspires others to produce. And I'm sure most of us in our lives have had like a friend who just really enjoys doing something, they're really good at it, and therefore you enjoy it more and you produce more. That's kind of person I'm talking about. And then you've got the shirker. This is the person who does enough to get by, but generally costs other people at least a little bit. The shirker avoids increasing effort. The poser just wants to stand out. The poser is always on the lookout for something better. They often add to productivity, or at least appear to add to productivity, but they impose indirect costs on those around them. The purpose of these models is to see how these interact and what macro level outcomes there are. Specifically, are there stable, either dynamic or static outcomes? In addition, the interaction amongst the three personalities was of interest. So the model is meant to explore three things: the effects of three things. The distribution of personalities in the population, the density of the population, and the effects of the length of the agent's memory on OVLR patterns. And then finally, the differences between measuring absolute versus relative, or absolute performance versus change in performance. So those are the conditions that I wanted to explore.
While creating this model, what were some of the biggest obstacles you encountered? And was there anything particularly challenging when simulating the, effects of different personality types on workplace dynamics or how the environment influenced them?
So the first challenge was just developing the personalities and decision rules, and I think this is pretty much the same for every kind of agent-based model. We also had some challenges just with performance and measurement issues. Figuring out what to measure is never the easiest thing, and you're always going to change your mind as you go through your project and you start discovering new things or finding out something else you're looking at is relatively trivial. So I did get interested in the composition of each agent's two-step neighborhood, which is why I put the index of qualitative variation into the model. But at this point, I think when I really try to dig into the model in the future, I'm going to just have to get the raw data out and take a look at that, so I'm not limited to just what I built into the NetLogo model itself. Performance is pretty generic, and it's used a lot when you look at organizational behavior, particularly in the business schools, and it's heavily criticized. In this case, I just needed a generic sense of what's the output. The thing here that's kind of odd is there's no floor, right? Is you can actually go very, very low, and there's nothing in the model to sort of police the organization like you would have in a company that is suddenly losing lots of money. Now, this may not sound realistic in some environments, but in others it is. So I left it there. Performance is very much just is a very abstract measure. Visualization, since I'm a very text-based person, was a little bit of a challenge, but I'll spare you that because I think most people who do modeling are probably pretty good at visualization. Verification and validation of the model is something that haunts everybody who does any kind of a model, agent-based or not. Verification is relatively simple, just making sure the code works. Now, validation in this case really isn't possible because I'm not trying to emulate a specific empirical environment. What I was really looking at is, how do I get a model which allows me to look at situations differently, real situations differently, and thereby aid understanding.
And now let's discuss what you have discovered from running different simulations. What key patterns have emerged from analyzing the model?
There are some things that I've discovered doing a lot of the exploratory work, which I think are worth looking into at a more rigorous level. The first obvious question was, is there a difference in the agent's behavior or in the model results if you use rate of change versus absolute performance? And there definitely is. If there hadn't been, this whole thing would be sort of for naught, and I would have abandoned it. The second thing is that memory does appear to matter. That the window length, which is how long the agents average the performance or average the rate of change in performance, does have an effect on the agent's behaviors, performance, and their happiness. In general, longer tends to seem to work differently, but it's more interesting than that. When you look at it, if you vary that window length during the simulation, you'll actually see different macro level behaviors in some of the measurements. Population density is one that you should always check for because, again, following a lot of famous models that have been around, this has a lot of effect, and it definitely does. Interestingly enough, lower density means workers are generally happier. Posers are generally less happy under those situations. Paradoxically, the poser is happier when there are fewer opportunities to move, which occur in the high density populations. Denser populations in the simulation mean that they're affecting each other more than in the sparse simulations. So we have a couple of paradoxical results. Posers may actually be the happiest when they're the largest part of the population. This is something I have to test over a number of different initial conditions. When shirkers are the largest segment of the population, posers seem to be relatively happy, which you would think is kind of strange, but that might cause you to go back and think about where you work and how shirkers and posers and workers relate to each other. But when workers are the largest part of the population, posers tend not to be as happy. And this would seem somewhat counterintuitive, but when you start thinking about it, it's actually not. It's because the workers tend to associate with each other quite a bit, which makes it more difficult for the posers to get into a better performing space.
You have shared your model through comsys.net. What challenges did you face in making it available to others using this website? And how did you ensure that the model was well documented for other researchers?
So it was, I had it reviewed by some colleagues of mine before I posted it, and then I asked for it to be peer reviewed when I submitted it, so it would get, so I'd have a better check on the code and the explanations and so forth and what worked. It includes a more or less following some of the standard guidance about regarding model documentation is included with it to try and make it very clear.
What do you see, as the next steps for this model? Are there any upcoming, enhancements or new studies to explore workplace dynamics further?
So when they left off with this project, I was at a decision toward two decision points. Is there a decent chance of getting some insights that are useful? And should I change the underlying design at all? I think the answer, looking at to the first question, is yes. There's never any guarantee in this, but I think the risk is probably worth it. There were some trivial outcomes at first, but I've got a few that I mentioned which I think are worth exploring. The second question is sort of a qualified yes. The first thing is what's to measure. As I mentioned before, that's something that changes through projects like this as you discover some things are interesting and other things are not. What I really want to look at, I think, are more micro level measures or local measures, whereas right now it's mostly oriented around macro level measures in the entire simulation. A really big one, which I tried at first, and it would turn out to be completely trivial, is to have a learning decision rule. Right now, all the decision rules are reactive. And the learning decision rule I tried at first just turned into a real mess and didn't go anywhere. I think the ones I'd like to try from here are weighting the window, because right now it's just a straight moving average, but a weighted moving average to see whether closer things in time or further things away in time actually matter. And it would be really fun to get one that's adjusted by each of the agents during the simulation to see just what you get. Again, could be trivial, but I think that's at least looking at a weighted moving average would be very interesting. Exit and entrance into the model, I tried that again. It was kind of trivial, but to allow agents who say are unhappy for a certain length of time to just leave instead of moving around. and then bring some in. Otherwise, you depopulate probably. But that's one where I tried once. I really haven't gone back to give it a good think. At first, it was kind of trivial. One thing I'd really like to do is allow sort of mixed perspectives. Because right now, all the agents are either choosing their decision rule either operates on the rate of change or the absolute performance, is to mix them together and to see if you have people or agents that are operating by different perspectives that way, whether you get changes in outcomes. And then finally, and this came about, quite frankly, when I was doing my prep work for this interview and going over it, was to allow some interventions. The code was originally written to just, you set the initial conditions and go. And I was playing around with it, and you can see, for example, changes in the behavior in the model at the macro level when you change the length of the window. It really wasn't intended for that, so sometimes it doesn't work very well. But I tried it enough to say I think this is another one to look at, is that if you intervene and get the agents to either have a shorter or longer window, then it does actually change their behavior. So those are some of the things that I'm interested in looking at, and where I'd like to take the model from here.
Thank you very much for sharing your insights into this model.
Well, thank you very much for the opportunity. I really appreciate it. And again, I really appreciate the project you're running.